Astronomers tracking 3I-ATLAS say it has altered its course, worrying scientists about its close proximity to Earth.
We've got some fresh images of 3I-ATLAS, a third ever interstellar object observed from Earth, currently racing through our solar system. Now, astronomers have captured that moment live.
NASA has officially confirmed the anticipated arrival date of the interstellar object designated 3I-ATLAS, and the announcement has stirred both scientific communities and the general public alike. This confirmation represents a landmark moment in astronomy, as only a handful of interstellar visitors have ever been detected passing through our solar system. The arrival of 3I-ATLAS promises not only a chance to study a body that originates beyond our solar neighborhood, but also a deeper look into the history and structure of matter that has traveled unimaginable distances across the galaxy. With the confirmation of its trajectory pointing it toward Earth's vicinity, researchers are preparing for an unprecedented opportunity to gather data that could reshape our understanding of the cosmos. Before we start, smash the like and subscribe buttons for more updates. The designation 3I-ATLAS indicates that this is the third confirmed interstellar object after the historic detections of Oumuamua in 2017 and 2I-Borisov in 2019. Those earlier discoveries revealed that interstellar objects are far from theoretical oddities. They are real travelers crossing the great expanses of interstellar space, carrying with them chemical and physical signatures of other star systems. 3I-ATLAS now joins this exclusive list, and unlike its predecessors, astronomers have had more time to track, model, and prepare for its close approach. This extended preparation window is invaluable because it allows telescopes on Earth and in orbit to coordinate observations, while space agencies consider how to maximize this once-in-a-lifetime encounter. The confirmed arrival date of 3I-ATLAS is significant because it sets the stage for the most comprehensive study of an interstellar body ever attempted. Unlike Oumuamua, which was already leaving the solar system by the time astronomers noticed it, 3I-ATLAS has been monitored in advance, giving planetary scientists a roadmap of its trajectory. This preparation ensures that as the object moves closer, spectrometers, radar, and other observational instruments will be primed to capture critical details about its structure and composition. For scientists, the opportunity is akin to having a probe sent from another star system arriving at our doorstep without any effort on our part. The implications of this encounter extend well beyond pure astronomy. Interstellar objects act as messengers, carrying ancient materials formed in environments far removed from the conditions that shaped our own solar system. By analyzing the light reflected off 3I-ATLAS, scientists hope to identify the unique mix of ices, metals, and organic compounds that make up its surface. Each chemical fingerprint provides clues about the star system in which it originated. Was it born in a region with abundant heavy elements? Did it form in the icy outskirts of a stellar nursery similar to our Oort cloud? These questions are now closer than ever to being answered thanks to NASA's confirmation of the arrival date. Another layer of fascination comes from the object's trajectory. While NASA has confirmed that 3I-ATLAS is heading toward Earth's vicinity, it is important to stress that its path will take it near our planet, not directly into it. Still, the terminology of heading toward Earth has captured imaginations worldwide because it emphasizes the rare chance to observe something alien in origin as it sweeps close to our cosmic neighborhood. This trajectory also means amateur astronomers may be able to glimpse the object using powerful backyard telescopes, making 3I-ATLAS not just a subject of professional research, but also a spectacle for the wider public. What sets 3I-ATLAS apart from earlier interstellar visitors is the timing of its discovery. With modern survey systems like the Asteroid Terrestrial Impact Last Alert System ATLAS, scientists have a much more robust early warning capability than they did even a decade ago. ATLAS itself is designed to detect near-Earth objects that could pose threats, but its sensitivity has also proven invaluable for catching interstellar travelers. In this case, 3I-ATLAS was spotted with enough lead time to chart a careful observation campaign. The confirmed arrival date now ensures that resources can be pooled globally, with observatories in different hemispheres taking turns tracking its journey. The excitement surrounding the event is not limited to astronomy alone. The arrival of 3I-ATLAS carries philosophical weight, sparking conversations about humanity's place in a galaxy filled with countless worlds and systems. Each interstellar object is a tangible reminder that our solar system is not an isolated bubble, but rather part of a vast and dynamic galaxy where matter flows freely across unimaginable distances. In some ways, 3I-ATLAS is like a visiting envoy from another star, carrying secrets from a place we may never physically reach with spacecraft. For planetary defense researchers, this event also holds practical lessons. By monitoring the trajectory of an interstellar object heading toward Earth's vicinity, teams can test models that predict motion across gravitational fields, solar radiation pressure, and other forces that act on a body traveling at extreme velocities. These lessons are crucial not only for understanding harmless passers-by like 3I-ATLAS, but also for preparing strategies in case one day a larger body on a collision course with Earth is detected. Each encounter sharpens the tools humanity has to safeguard its planet. The sheer velocity of interstellar visitors makes them especially compelling. 3I-ATLAS is traveling at a speed that ensures it cannot be gravitationally bound to our Sun. This high velocity confirms its origin beyond the solar system, and it also makes observations challenging. Instruments must be ready to capture data quickly as the object whips through the inner solar system before disappearing forever into the blackness of interstellar space. The confirmed arrival date gives astronomers the certainty they need to fine-tune their schedules and ensure no moment of observation is wasted. Astronomers are particularly eager to determine the shape and size of 3I-ATLAS. Oumuamua's elongated cigar-like appearance stunned the scientific world and inspired debates about whether it was a natural object or something more exotic. Borisov, on the other hand, more closely resembled a comet, with a visible tail as it released gas and dust. 3I-ATLAS may fall somewhere in between, or it may reveal entirely new structural characteristics that defy current classification. Every image and spectrum gathered will contribute to a comparative catalog of interstellar bodies, deepening our understanding of the diversity of planetary formation beyond the Sun. The study of 3I-ATLAS also feeds into astrobiology. Organic molecules, the building blocks of life, are known to exist in comets and asteroids. If 3I-ATLAS carries such molecules, they could provide evidence that the seeds of life are widespread in the galaxy, moving between star systems on icy rocks like cosmic couriers. While no one expects life itself to be traveling aboard this object, the presence of complex chemistry would strengthen the case for panspermia theories, which suggest that the ingredients of life can spread between worlds and systems. This interstellar visitor thus becomes more than just a curiosity. It becomes a test case for questions about life's potential universality. The announcement by NASA has already triggered excitement in scientific institutions around the world. Plans are underway for coordinated international observations, with agencies in Europe, Asia, and the Americas aligning telescope time and sharing data in real time. This collaborative spirit reflects the recognition that 3I-ATLAS is not just a NASA discovery, but a human one belonging to all of humanity's collective pursuit of knowledge. The confirmed arrival date serves as a rallying point, ensuring that researchers everywhere can prepare to unlock the mysteries of this galactic wanderer. As the days count down to its closest approach, anticipation will continue to build. News outlets, science communicators, and educators will seize the opportunity to inspire the public with the story of a rock that began its journey countless millennia ago in another star system and is now passing by our home world. The story of 3I-ATLAS is a story of cosmic interconnectedness, of distant origins converging with human curiosity at precisely the right moment in history. The implications for future missions are also profound. If the study of 3I-ATLAS yields particularly exciting results, it may fuel momentum for proposals to send rapid response spacecraft to intercept future interstellar objects. Missions could be designed to rendezvous with these bodies, sampling their materials directly and returning them to Earth. The confirmation of 3I-ATLAS's arrival makes the theoretical future of interstellar exploration feel far more tangible, because it highlights how frequent such visitors might actually be and how much we stand to gain by being ready. Even before its arrival, 3I-ATLAS is serving as a catalyst for scientific dialogue. Questions are being asked not only about its composition, but also about its dynamical history. Which star system did it originate from? How long has it been traveling? Did it pass near other stars before entering our solar system? Answering these questions will require sophisticated simulations and backward trajectory analysis. linking its path through our system with models of stellar movements in the local galactic neighborhood. Such work extends far beyond the object itself, offering insights into the larger gravitational choreography of our corner of the Milky Way. The confirmed date of arrival ensures that 3I-ATLAS will not simply be a fleeting curiosity like its predecessors. It will be studied, documented, and remembered as the interstellar visitor that humanity was ready for. Instruments across the globe will be pointed skyward, gathering terabytes of data as scientists squeeze every bit of information out of its brief passage. The knowledge gained will echo across disciplines, enriching not only astronomy but chemistry, physics, planetary science, and even philosophy. As the world looks forward to this cosmic encounter, the excitement is tinged with awe at the vastness of the galaxy and the smallness of our place within it. Yet it is precisely this awareness that makes the event so inspiring. 3I-ATLAS reminds us that the boundaries between star systems are not barriers but pathways along which matter drifts, carrying stories from one stellar cradle to another. With NASA's confirmation of its arrival date, humanity has been handed an invitation to listen closely to one of those stories, and in doing so, to deepen its understanding of the universe it inhabits. The confirmation of 3I-ATLAS's arrival date has done more than validate astronomical calculations. It has unlocked a deeper historical appreciation of how humanity's relationship with the skies has evolved. For centuries, civilizations have gazed upward, charting the stars and recording the movements of wandering bodies. Ancient astronomers who tracked comets with the naked eye could never have imagined that their descendants would one day measure the approach of an object that originated outside the solar system itself. The continuity of human curiosity, stretching from early skywatchers to modern astrophysicists, gives this event a profound cultural and historical resonance. It connects the wisdom of past generations to the technological prowess of the present moment, demonstrating how the human drive to understand the heavens has persisted and matured. Historically, interstellar encounters were relegated to the realm of speculation and imagination. The idea that other star systems might eject icy fragments or rocky bodies into interstellar space was theoretically plausible, but the ability to detect them was absent. Only in the 21st century did advances in wide-field survey telescopes make it possible to identify fast-moving objects with unusual trajectories. The confirmation of 3I-ATLAS's arrival date therefore represents the fruition of decades of technological progress and scientific patience. It is not simply the discovery of a rock traveling through the solar system, it is the culmination of humanity's expanding observational reach. A triumph of persistence against the vast backdrop of cosmic time. What makes 3I-ATLAS particularly striking is how it forces astronomers to reassess the scale and diversity of interstellar traffic. Each confirmed interstellar visitor implies that countless others pass undetected, moving silently across the darkness. If 3 such objects have been identified within just a few years, the logical conclusion is that interstellar fragments are far more common than previously assumed. This realization reshapes models of galactic dynamics and planetary formation, suggesting that stars and their surrounding disks shed debris more prolifically than once believed. In this sense, NASA's confirmation of the object's arrival date is not just a calendar note, it is a data point that broadens humanity's sense of how lively and interconnected the galaxy truly is. The technical achievement behind the confirmation also deserves its own attention. Pinpointing the trajectory of an interstellar body is a formidable task. These objects move at extraordinary velocities and follow paths that are strongly influenced by the gravitational pull of the sun, planets, and even smaller bodies. Determining when 3I-ATLAS would arrive near Earth's orbital region required meticulous observation, precise measurement of its brightness and position over time, and sophisticated mathematical modeling. It is a testament to the capabilities of modern astronomy that such a complex dance can be charted with confidence. The process demonstrates the precision of contemporary orbital mechanics, where even an alien body racing across interstellar space can have its rendezvous with Earth's neighborhood predicted down to the day. The global scientific community has responded to this confirmation with remarkable unity. Astronomers from multiple continents are coordinating observation schedules, ensuring that as 3I-ATLAS approaches, no detail will go undocumented. This collaboration underscores the universal appeal of cosmic discovery. It is not a matter of national pride or institutional competition. Rather, it is a shared endeavor, a moment when borders dissolve in the face of a common cosmic opportunity. Observatories in the southern hemisphere will take over when northern instruments can no longer track the object, and data will flow across the globe almost instantly. The arrival of 3I-ATLAS thus becomes not only a celestial event, but also a symbol of international cooperation in the pursuit of knowledge. While much attention focuses on the scientific implications, the cultural impact of this event cannot be understated. Throughout history, comets and unusual celestial phenomena were often interpreted as omens, shaping mythology, literature, and even political decisions. The appearance of 3I-ATLAS, with its confirmed trajectory toward Earth's skies, will inevitably inspire new cultural reflections. Artists, writers, and philosophers are likely to draw inspiration from the image of a messenger from another star system sweeping past our planet. Such encounters remind humanity that the cosmos is not static, but dynamic, a stage upon which events unfold that can ignite imagination as much as they enrich scientific understanding. The event also sharpens the sense of scale when contemplating the Milky Way. Each star system has its own history of planetary formation, and each likely ejects fragments into interstellar space. 3I-ATLAS is one such fragment, but it is representative of an entire population that roams unseen. The galaxy, then, is not an empty void between stars, but a highway of countless icy and rocky travelers. Recognizing this reality alters how scientists perceive interstellar space. It is not a sterile vacuum, but a medium through which matter circulates, bearing the imprints of stellar birth, planetary collisions, and gravitational upheavals. The confirmed arrival date of 3I-ATLAS provides a rare anchor point, a moment when one of these unseen wanderers briefly steps into the light of human awareness. The confirmation also compels a closer examination of how interstellar objects interact with the heliosphere, the bubble carved out by the solar wind. As 3I-ATLAS moves through this boundary region, scientists will have an unprecedented opportunity to study how material from beyond reacts to the charged particles streaming outward from the sun. This dynamic interaction can shed light on both the protective shield that envelops our solar system and the physical properties of the visitor itself. Every observation will deepen the understanding of how local and interstellar environments blend at their boundaries. Another fascinating aspect lies in the unpredictability of what telescopes may reveal. The prior interstellar visitors each brought surprises that defied expectations. Oumuamua's unusual acceleration baffled scientists, while Borisov's clear cometary activity highlighted its pristine interstellar ice. 3I-ATLAS may present its own unexpected characteristics, perhaps a rotational pattern unseen before, a surface composition rich in exotic minerals, or a brightness variation hinting at a complex shape. By confirming the arrival date, NASA has effectively set the stage for these surprises to unfold in real time, with astronomers and the public watching eagerly. Beyond immediate science, the announcement has reinvigorated discussions about the future of rapid response space missions. Concepts for spacecraft capable of intercepting such objects have long existed, but until now, the short notice of prior discoveries made them impractical. The advanced confirmation of 3I-ATLAS shows that with adequate detection infrastructure, humanity could one day dispatch missions to interstellar bodies before they arrive. This realization strengthens the case for investment in flexible, high-speed probes that could launch on short notice. Such missions would not only transform the understanding of interstellar materials, but also provide stepping stones toward deep space exploration. For educators, 3I-ATLAS offers a golden opportunity to inspire students. The event translates abstract ideas about interstellar space into something tangible, something that can be seen through telescopes and discussed in classrooms. Teachers can frame lessons around the object's journey, its origins, and the methods used to track it, showing students that astronomy is not a static discipline, but one filled with real-time discovery. The confirmed arrival date allows educators to prepare activities, public viewings, and educational campaigns that will engage young minds, perhaps sparking the next generation of astronomers. The event also resonates strongly with the broader public fascination with the unknown. Humanity has always been captivated by the idea of visitors from beyond, whether in mythology, science fiction, or speculative thought. The confirmation of 3I-ATLAS's arrival provides a rare instance when such imaginings intersect with reality. Though the object is a natural body, not a spacecraft, it embodies the spirit of otherness, a true emissary from the stars. This blend of reality and imagination ensures that the encounter will ripple across popular culture, inspiring stories, films, and creative works long after the object has departed. In the realm of planetary science, the confirmed date also opens the door to comparative studies. Researchers will contrast 3I-ATLAS not only with previous interstellar visitors, but also with comets and asteroids native to the solar system. These comparisons can reveal the unique fingerprints of local versus interstellar formation processes. If the chemical ratios in 3I-ATLAS differ significantly from those in known comets, for example, it will suggest that planetary systems elsewhere evolve under very different conditions. Such distinctions will refine models of planetary system diversity, helping scientists understand whether the architecture of our solar system is typical or unusual in the galaxy. The anticipation surrounding 3I-ATLAS also highlights the increasingly interconnected nature of astronomical observation. Modern technology allows not only professional observatories but also citizen scientists to contribute valuable data. With affordable telescopes and digital imaging, amateur astronomers can track the brightness of 3I-ATLAS, adding to the global database. NASA's confirmation of the arrival date has effectively opened the door to this broader participation, transforming the event into a collective enterprise that bridges professional and amateur astronomy. Another unique aspect of this encounter lies in its role as a stress test for communication systems. Coordinating global observations requires rapid data sharing across continents. The arrival of 3I-ATLAS provides a real-world scenario to refine the infrastructure that enables such cooperation. From cloud-based data repositories to real-time alerts, the systems developed for this object will lay groundwork for future events, ensuring that when the next interstellar traveler arrives, humanity will be even better prepared to observe and understand it. The significance of this confirmation also extends into the philosophy of science. Events like this challenge the boundary between the known and the unknown, forcing researchers to adapt theories and confront surprises. 3. I-ATLAS is not simply an object. It is a reminder of the limits of prediction and the necessity of openness to discovery. By confirming its arrival, NASA has highlighted the humility inherent in science, the recognition that the universe continually presents phenomena that stretch the imagination and compel new understanding. Even in fields far removed from astronomy, the event is generating conversation. Futurists and thinkers in disciplines such as anthropology, psychology, and sociology are considering how humanity perceives and responds to cosmic phenomena. The arrival of an interstellar body prompts reflection on identity, perspective, and destiny. It asks individuals and societies to think beyond terrestrial concerns and consider themselves as participants in a cosmic drama. This mental shift, though subtle, is one of the most profound implications of events like 3I-ATLAS's passage. The confirmation also serves as a reminder of the fragility of observation windows. Interstellar objects pass quickly, and once they are gone forever. This fleeting nature lends urgency to the scientific response. Every hour of telescope time, every spectrum collected becomes a precious piece of evidence, unrepeatable and irreplaceable. In this sense, NASA's announcement is also a call to action, urging the global scientific community to seize the moment with full attention and effort. As the confirmed date draws closer, simulations and visualizations will play an increasingly important role in public engagement. Scientists will produce models of the object's trajectory, showing how it arcs through the solar system and approaches Earth's vicinity. These visualizations not only aid scientific understanding, but also help the public grasp the magnitude of the event. They transform abstract orbital data into vivid imagery, enabling people everywhere to feel connected to the passage of this alien body. The excitement is not confined to Earth. Instruments aboard spacecraft throughout the solar system may also be tasked with monitoring 3I-ATLAS. Probes in different locations could provide unique vantage points, capturing data that Earth-based observatories cannot. This multi-platform approach would maximize the scientific return, offering a holistic view of the object from multiple perspectives. The confirmed arrival date makes such coordination possible, giving mission planners the lead time needed to adjust priorities and commands. Even as astronomers prepare for the encounter, theoretical astrophysicists are modeling how objects like 3I-ATLAS are born and expelled from their home systems. The event fuels investigations into the dynamics of young planetary systems, where gravitational interactions between massive planets can fling smaller bodies outward at incredible speeds. The confirmation of 3I-ATLAS's arrival strengthens these studies by providing a concrete case that can be compared with simulations. The result is a deeper understanding not only of one object, but of the mechanisms that populate the galaxy with interstellar wanderers. In the broader narrative of exploration, the confirmation of 3I-ATLAS's arrival date feels like a rehearsal for encounters yet to come. Each visitor is a rehearsal, a practice round in humanity's long journey toward reaching other stars. While interstellar travel remains far in the future, studying interstellar debris gives a glimpse of the materials and environments that lie beyond. It is as if the universe, recognizing the limitations of current technology, sends emissaries to us, offering samples and stories from faraway places. The arrival of 3I-ATLAS, confirmed and awaited, is one of those gifts. Perhaps the most stirring aspect of all is the sense of continuity this event creates. Generations alive today will witness something extraordinary, and their accounts will join the growing history of interstellar encounters. When future objects are discovered, they will be measured against the standard set by 3I-ATLAS. Each detection builds upon the last, weaving a larger tapestry of understanding. The confirmed arrival date marks a milestone in that unfolding story. A chapter that will be remembered as the moment when humanity recognized not just the rarity, but the rhythm of interstellar visitors. As the countdown continues, anticipation builds not just in observatories, but in living rooms, classrooms, and public forums. People everywhere will look up at the sky, aware that a traveler from beyond the solar system is sweeping past. That shared awareness is itself a powerful phenomenon, uniting billions in a fleeting moment of collective wonder. The confirmation of 3I-ATLAS's arrival ensures that this awareness will not be vague or uncertain, but focused and precise, turning a cosmic event into a shared human experience. When NASA confirmed the arrival date of 3I-ATLAS, one of the subtler but equally important ripples spread into the realm of public psychology. For decades, news about space has alternated between awe-inspiring discoveries and sobering reminders of hazards such as asteroid impacts or solar storms. The announcement about an object from another star system arriving near Earth carries neither the doom of impending catastrophe nor the dry abstraction of distant data. Instead, it evokes a sense of collective anticipation. People who might never have heard of orbital mechanics now find themselves following countdowns, eager to witness a brief moment when their planet shares space with something born under a completely different sun. This emotional charge is rare in scientific communication, and it highlights how astronomy can transcend technical boundaries to become a cultural event. The sense of awe is amplified by the sheer antiquity of the traveler. 3I-ATLAS is likely older than the solar system itself, having spent eons adrift in the cold between stars. When people consider that this object may have been wandering for billions of years only to arrive within human lifetimes, the coincidence feels staggering. Such timing reinforces the feeling that humanity occupies a privileged, if temporary, position in cosmic history. That awareness brings with it humility, reminding people that while human civilizations rise and fall in the blink of galactic time, the universe continues its slow, majestic unfolding. This event also illuminates the role of technology in shaping perception. Modern telescopes, both on Earth and in orbit, can track faint points of light invisible to the naked eye, translating them into meaningful stories for the public. The confirmed arrival of 3I-ATLAS underscores how dependent humanity has become on technological mediation for its sense of cosmic place. Where once people watched comets blaze overhead in wonder, now they rely on arrays of digital sensors, supercomputers, and space-based observatories to reveal visitors that would otherwise remain unseen. This reliance is not a weakness, but an expansion of human senses, an example of how instruments have extended awareness far beyond natural limits. Another dimension of the announcement is the way it fuels momentum for building even better detection systems. If 3 interstellar objects have been found in such a short span of years, there may be hundreds passing unnoticed every decade. That realization places pressure on governments and institutions to invest in wide-field survey telescopes, infrared detectors, and even space-based observatories dedicated to scanning the skies continuously. Confirming the arrival of 3I-ATLAS demonstrates the payoff of such infrastructure. It is a case study in why proactive monitoring is essential not only for planetary defense, but also for scientific discovery. The clearer the skies are watched, the more frequent such encounters will become, transforming interstellar science from a rarity into a routine branch of astronomy. For policymakers, the arrival of 3I-ATLAS provides a striking illustration of why investment in space science matters. Budgets for astronomy often compete with more immediate terrestrial priorities, but moments like these justify long-term planning. When an alien visitor approaches, carrying with it data about environments unreachable by spacecraft, the return on investment becomes evident. Every image, every spectrum captured from 3I-ATLAS will be leveraged by hundreds of scientists, generating knowledge that ripples outward into textbooks, models, and even future mission concepts. The cost of detection pales compared to the cultural and intellectual enrichment it provides, strengthening the argument for sustained support of astronomical infrastructure. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA confirming 3I-ATLAS arrival date toward Earth? We want to hear from you. Thank you for watching, and see you next time.